Good day, ladies and gentlemen, and welcome to this video. In today's video, we're going to be looking at ESSRT page number 12. Finally, we are on this page. So I'm going to be leaving out all of the details that we've learned over the last 2 weeks about conversion plate boundary, diversion plate boundary, and transform plate boundary. Don't forget the details. I'm just leaving them out in this video so that we don't make this video any longer than it needs to be. But I'm going to just give a quick summary of everything that we've learned over the last few weeks. Now, in front of you is a more colorful, vibrant representation of page number 12, showing all the major tectonic plates and tectonic boundaries that we have all around the world. Your page number 12 looks more or less like this. Okay. All right. So we're going to get started with the key, which is at the bottom of your ESSRT page number 12. And the first plate boundary we're going to be considering here is the divergent plate boundary. Now, this is the region where two plates are separating. So it's represented with a thick continuous line with arrows pointing in opposite direction, representing the relative movement of the two plates that are separating. So we have, for example, this major one in the Atlantic Ocean going in that manner. So that definitely is a divergent plate boundary, and there are many more on your screen as you can see. Just below that symbol is another symbol again representing a divergent plate boundary, but this time around there is a number attached to it. In this case, it's 7.4, and that represents the total spreading rate in centimeter per year. That is letting you know how fast the two plates are separating from each other in centimeter per year. For example, when you look at this region in the Southeast Indian Ocean region, the two plates, which is Antarctic plate and the Indian Australian plate, those two plates are separating in these two regions at a speed of 7.4 centimeter per year. So if you look all around on each of the divergent plate boundary, you're going to see various numbers attached to it. Here we have 1.80, here we have 2.5, here we have 3.8. In the East Pacific rise, we have 15.3, 16.1. All of those numbers just lets you know the rate, the speed at which the two plates are separating from one another. Next, we are going to be considering the major active fault zone. Now, fault zone are usually associated with transform plate boundaries, so don't forget the symbol for transform plate boundary in here as well. Now, common example of active fault zone is somewhere around the Caribbean, between the Caribbean plate and the North American plate. So you see that fault line or that fault zone in that part of the world. You would also see other ones around, mostly not having the arrows indicated on them. That just indicates that there is a fault in that area. Now, compared to the transfer plate boundary, you have arrows pointing in opposite direction, and that lets you know the direction in which each of the plates are going in that area. So, about transform plate boundary, we have several of them in that part of the Eurasian plate, and another one here and another one below there. We also have a transform plate boundary here, transform plate boundary there, transform plate boundary here, transform plate boundary this in the San Andreas Fault in California, the west side of United States. Um, and of course, all around, if you look all around, you're going to see more of the transfer plate boundary in there. Okay, so next we're going to look at normal fault. Here it indicates, lets you know that this is a normal fault, and the hashed line shows you the down thrown side. What that simply means is the fault that went down, or the block or the plate that went down. That is the down thrown fault. For example, let's take a look at these. Let's see where we can find a good example right around here. So that is the fault line, but it lets you know that this side of the fault line is what was downthrown, because that's where the hash line is pointing to. Again, the hash line is that, and then you have this hair-like thing growing out of it. So that's what we refer to as the hash line. So wherever the lines are going to us, that shows you the downthrown side of that fault. Next is the convergent plate boundary. Convergent plate boundary where two plates are coming together. Now remember, the triangles is pointing to the plate that is overriding, while the other plate on the smooth line is the subducting plate. So, for example, in the Chile-Peru convergent plate boundary, the Nazca plate is the one subducting because it is the one on the smooth side of the symbol, while the South American plate is the one overriding because that is where the triangles are pointing towards. So don't forget that. So wherever you see the triangles are pointing towards, that tells you the plate that is overriding. And as you know, the overriding plate is what gets the mountain, is where the mountains are going to pop up on. So in this Chile Peru trench, we'll see that the mountains will be on this side of South American plate. The mountains will be on this side of United States. Over here, the mountains will be on this side. So the triangles on the convergent plate boundary are always pointing towards the plate that is overriding, which is where the mountains or the highlands are going to occur. So in my head, I just picture that the triangles pointing towards the mountains. If that makes sense. Lastly, we're going to be looking at uncertain plate boundary. What this means is these plate boundaries, they are complex. So in some maps, or you hear some other scientists saying complex plate boundary, what this refers to is that there is no definition of how these plate boundaries are behaving, whether they are separating or whether they are meeting or whether they are just transforming. It is uncertain or it is complex. Scientists don't know for sure what's going on there, maybe because it's a combination of all of these things together, or scientists are just completely uncertain. So for such, you're going to find complex plate boundaries somewhere around this area of North America, and then broken line. So the uncertain plate boundary is represented by broken line. So surrounding the Scotia plates, around that area, you have a complex plate boundary there again, and a few more others here. There's also a complex plate boundary. There's also a complex plate boundary in that region. And then some other places if you look hard enough. So with constant practice, and as we look at this page more, we're gonna get used to each of these plate boundaries, where they can be found, and how we can extract information from this page to answer some of the questions that we're gonna be looking at. Speaking of questions, that is the next thing we should be doing right now. And hopefully this page makes sense, or make more sense to you now. So let's take a look at some of Regent's questions, and then we wrap up this video. Now I've put in the page number 12 on the screen here so that we can make reference to it as we answer these questions. Question number 1 here says, base your answer to the following question on your earth science reference table, the map below, and your knowledge of earth science. The map shows the island of Hawaii approximately 20 degrees north and 57 degrees west, and the location of recent volcanic eruptions and earthquake epicenters. These volcanic eruptions are inferred to be caused by the movement of lithospheric plates over a hotspot in the mantle below. So you have all of those diagram and all of those information, and the question is asking, Hawaii is located in the middle of which tectonic plate? In the middle of which tectonic plate? So we're looking at the tectonic plate. Hawaii is in the middle of one of them, and that's what the question is asking. Now, what do we know about Hawaii? Hawaii is, according to the question, is 20 degrees north and 57 degrees west. So if you look at your page number 12, it does indicate the lines of latitude and the lines of longitude. So for example, the first line of latitude, which is the equator, is 0 degrees. So you can see that 0 degrees is right there. And then you can see that 45 degrees is next. That is 45 degrees north. And then there's 45 degrees south as well. So you have to make these imaginary lines and this imaginary connection as you go along. Then in terms of longitude, we also have those lines there. We have the prime meridian, which is 0 degrees. Now the prime meridian connects to the other prime meridian, 0 degrees there. And then next to them is 90. So the 90 would connect to that 90, the 90 connects to that 90, and then you have the 180 connecting in that manner and 180 connecting in that manner as well. So this should give you, or this should help you quickly locate some of the plates that some of the questions might be referring to or talking about. In this case, Hawaii is 20 degrees north. So if this is 0 degrees, I know Hawaii is going to be on top 0 degrees, on top the equator, because it says 20 degrees north, which is on top. So if this is 0 degrees and if this is 45 degrees, then 20 degrees probably would be around here. Then 57 west would be just right around that area as well. So that brings us to Hawaii in that region there. And I can see that Hawaii is located on the Pacific plate. So our answer right now is Pacific plate. Now, the reason why I spent so much time in that, because I want you to understand that this page also gives you the information on longitude and latitude, and you can use those information to locate certain places all over the world. Not certain places, all places all around the world. The lines of latitude and longitude can easily be used to locate places. Question number 2. Seafloor spreading is occurring at the boundary between the, remember what we said about seafloor spreading? I'm going to underline that. What I do know about seafloor spreading is it is associated with divergent plate boundary, where the two plates are separating at the bottom of the ocean. So what I'm going to do here is I'm going to eliminate, look at these various options and then eliminate. Option A says between the African plate and the Antarctic plate. So I see the African plate around here and I see the Antarctic plate around here. So between these two plates, definitely there is a divergent plate boundary there. I see the thick continuous line, and on that thick continuous line, I see the arrows pointing in opposite direction. So A could be our answer. So I'm just going to put my eye on that. Nazca plate and South American plate. This is Nazca plate here. This is South American plate here. And the boundary between the two of them is convergent. It's a convergent plate boundary. Option B is out. China plate and the Philippine plate. This is the China plate. China plate is on the Eurasia plate. So if this is China plate and then this is the Philippine plate right here. So between China and Philippines, again, is a convergent plate boundary. Option C is out. Australian plate and the Eurasian plate. So I see the Indian Australian plate right around here, and I see the Eurasian plate here again. So when you look at it again, it's all convergence. It's all convergence in that region between the Indian Australian plate and the Eurasian plate. So that's convergent. So option A is the only divergent plate boundary going on here. Question number 3. Which location is closest to a divergent plate boundary at a mid-oceanic ridge? So we have several locations here. We have location A, location B, C, E, D, F. So it's asking out of all of these positions or location, which one is close to a divergent plate? Which is close to a divergent plate? So let's take option A. Option A is right on the edge of North America. So this is North America, right on the edge of North America. If that is a divergent plate at the edge, this is close to a little. Option A is really position A is kind of close to Mexico, so around Mexico in that direction there. Um, could that be a divergent plate boundary? I'm gonna put my. I'm just gonna. Let's see. Let's look at other option. Option B. Option B is right around here on the side of South America. So on the side of South America is a convergent plate boundary. Convergent, that is between the Nazca plate and South American plate. So we are looking for something that is divergent. So B is out. Location C is on the east coast of America. So on the east coast of America, I don't see any active plate in that region. So I don't think it's C either. Option E is on this land here. Looks like Greenland to me because it's just above Canada, on top of the North American plate, which is this structure right around there. And E is right around here. I don't see any plate boundary there either. So again, A is my option here. All right. So even though I wasn't sure about A, I have to do elimination for the rest just to be sure that A could be our answer. All right. Answer question number 4 again is with practice that you get to know more information about this page number 12. So it's all about more practice because we're looking at the entire word here. Question number 4 says at point A, the East Pacific Ridge is the boundary between the point A, which is right around here, is on the East Pacific Ridge, is the boundary between. So I'm going to look at my ESSRT page number 12, and I'm looking for the East Pacific Ridge, which should be a little bit to the left of South America. So this is South America here. So this is South America here. So once I see South America, I can see the East Pacific Ridge or rise right around there. So the question is asking that boundary is between what two plates? So according to my ESSRT page number 12, that plate boundary is between the Nazca plate and the Pacific plate. Nazca plate and Pacific plate. Couscous plate out, South American plate out, Pacific plate and South America out, Pacific plate and Nazca plate. That sounds like my answer. Option D. Finally, question number 5. What type of plate boundary represented in a diagram most likely exists between the type of plate boundary represented in a diagram most likely exists between so let's look at the diagram. The diagram here is showing a subduction zone here. So definitely this is a convergent plate boundary. So convergent plate boundary will exist between what two plates? That's what the question is indirectly asking. So out of all of these options, A, B, C, D, which one is a convergent plate boundary? Let's start with option 1, Antarctic plate and the African plate. So we have the African plate here, we have the Antarctic plate here. Between those two plates, we have a divergence. So our question is talking about convergence, so not divergence. So option A is out. Antarctic plate and the Indian Australian plate. Again, this is the Atlantic plate and this is the Indian Australian plate. And all of the boundaries between them, again, are all divergence. We are looking for conversion. So this is out. South American plate and Nazca plate. So this is South America, this is Nazca plate. And between those two plates, we have a convergence. That could be our answer. Option D, South American plate and African plate. So South American plate here, African plate here. Between those two continents, again, is a divergent plate boundary. So that is out. Our option, our best answer, validly remains option C. So this is how you're going to be using this ESSRT page number 12. It's a lot of information, but you just need more of the practice, and you need to pay attention to all of the details and all of the various landforms that can be created in these different plate boundaries, and where they are located, and how you can use the lines of longitude and latitude to easily locate these places on ESSRT page number 12. Bye for now.